Hello. In this video, we consider the effects of elasticity. Due to this elasticity, what are the different phenomena or different types of behavior possible for the elastic material? Okay. So the first thing is elastic after effect. Elastic after effect is nothing but the time taken by the elastic material to regain the original configuration after the removal of the deforming force. That means if you stretch a rubber band and you release it, it goes back by the restoring effect. But what is the time taken to come back to its original configuration? The time duration or time delay in gaining the original configuration is what we call elastic after effect. Now this idea is very important in the making of what we call moving coil, galvanometer, the suspension fiber. That the suspension fiber is to be having almost zero elastic after effect. That is very small elastic after effect that such a material is used in. Now, second one is elastic fatigue. Elastic fatigue. Fatigue. Fatigue means tiredness. Elastic tiredness. This is something like if you take a rubber band and you go on applying the deforming force, straining for a long time, repeatedly, you can find that the regaining effect of that rubber band is getting reduced slowly. That reduction in the regaining ability that you call the reducing the elastic effect is what you call elastic fatigue. By the continuous application of the stress, this is what is happening. And this idea is applicable for many places like building construction, the beam. When it is constructed, the engineers will be saying that building can be used for 30 years. After 30 years, it must be dismantled. Why this is so? This is because this beam, when they construct, will be having an elastic condition there that you can find that after that duration of time, the beam, horizontal beam, will be getting sagging, bending. You can see that all the bridges and all that we are not using, you can find that it is sagging, like maybe bending, broken, and it's all due to what is called this elastic fatigue. There are many cases there like that. Then the third one is what we call elastic hysteresis. Elastic hysteresis. Hysteresis, the word meaning is that lagging, going behind something. So what is actually this elastic hysteresis means? If I say load extension graph, this is extension, elongation produced, and this is load applied. Then initially when I go on adding that load, the elongation will be linear. It goes like this. Now after this, what happens is that I elongate it to a certain extent. Now I start unloading it, removing the weight attached gradually. When I start removing the load gradually, we expect that it must come back to the same path. No. You can see that the regaining is getting slowed down, and the slowness will be making that material to come back through another path, and it takes a very, very long time to come to the original shape. Now, as it is unloaded, initially when it is loaded, the elongation and the loading will be going directly proportional, but when it getting unloaded, the path is not being traced again. You can find that there is a lagging. Okay, regaining behind the load it is coming. So, in effect, we can say there is a lagging of strain behind the stress. Lagging of strain behind the stress is called elastic hysteresis. And this loop area you can consider for the energy distribution in the process. So using this elastic hysteresis of the material, you can select the material for shock absorbers and all that. So these are the main three effects of elasticity to be remembered. Okay? One more graph I will explain here is that according to elasticity, if I draw the stress strain graph, strain, stress. Then you can get a straight line graph, and this straight line portion is actually the region in which the Hooke's law is full. So actually this is an illustration of Hooke's law. And beyond the limit, this limit, this is the elastic limit, and beyond that the behavior of the material is something different. But within that limit, if I assume this graph, then if you find the area under the graph, what I get is nothing but energy density. Because this is area under the graph is nothing but half into stress into strain. Okay, that is also very important.